In this code, I have an article I created on zerodays.com, where I create a simple stealth zombie scan. It's a scanner that uses a zombie machine as a target. That's why I put the image of a stealthy American fighter jet here, to give context to the content. Before we start to understand, I created, or rather got from the internet, a diagram explaining the attack. Basically, every time I send or receive a packet in its header, this is where studying the OSI layer, TCP, IP protocol, etc. becomes important. Every time I send or receive a packet, it has an IP ID, which is the IP packet identifier in the response. If I'm not mistaken, it comes in the protocol header. So basically, I send a SYN ACK to the zombie machine and it sends back a reset. So I keep sending SYN ACKs to the zombie machine until it returns a reset packet with its IP ID. Why does it return a reset to me? It returns a reset because a direct SYN ACK isn't a valid protocol. You first send a SYN, not a SYN ACK. So as it doesn't accept a connection, it sends a reset and your IP ID, which is recorded, right, in our script. So after I got the IP ID of this machine I'm using as a decoy, right, as a zombie, right, I send a spoofed SYN to the target, pretending to be the zombie's IP ID. So everything goes through it. This packet will seem like it came from the zombie, but it didn't. It came from the attacker, right? So this is one of many examples of stealthy, undetectable attacks. Logical, right? The attack isn't 100% undetectable. Other things can lead to detection. Here I have an example with Nmap. Nmap already offers this attack type with the SI flag. On the blog, I also have a Python example using Scapy, which lets me manipulate network packets as I want. I won't go through the whole script, but it's simple and simulates this attack like Nmap, but simpler. It'd be ideal for you to check it out and test it, right? So we have these examples here on the blog.